Today we will be doing Chapter 5, which goes over the lipids, triglycerides, phospholipids, and sterols. So first, to get us started, having too much or too little fat can lead to either a good or a poor health. It's going to lead to a poor health. You need the right amount of fat in your diet. Fatty acids contain an even or odd number of carbons. They're going to all have even numbers. And triglycerides consist of that one glycerol and 3 fatty acid tails. Certain fats are essential to good health, and a well-balanced diet will ensure that you're getting the right amount of fat for the optimal health. And so remember that 1 gram of fat contains 9 calories, whereas remember the other 2 macronutrients, carbohydrates and protein, contain 4. So let's get a preview of the lipids. The lipids are a family of compounds, and they include either triglycerides, phospholipids, or sterols. We'll look at phospholipids and sterols later, but right now we're going to be going over triglycerides. Triglycerides consist of a glycerol and 3 fatty acid tails. The length of the carbon chain for those fatty acid tails can vary. It can either be 4 to 24 carbons. 18 is the most common, and that's seen as that saturated fat or the unsaturated fat in your foods. That's going to be that 18 carbon chain. There's specific names for that fat in particular. With the 18, for the saturated, it's stearic acid, and for the unsaturated, it's oleic acid for that monounsaturated. And then for the polyunsaturated, those are going to be called linoleic or linolenic acid. But that's just getting more into detail. The main thing is that right now the carbon chains, they can vary in length. And 12 to 24 carbon chain, that's going to be a long chain. Those are the fatty acids normally found in meats, seafood, and vegetable oils. But there are medium chain, which is 6 to 10, or short chain, which is anything lower than 6, that occur primarily in dairy products. And also with the differing lengths in those fatty acid chains, they also differ in their level of saturation. A fatty acid can either be saturated or unsaturated, and that depends on the number of double bonds or single bonds to the carbon chain with the saturation of hydrogens. And in a triglyceride, few fatty acids are free in foods or in the body. Most are incorporated into the triglyceride. The lipids are formed by condensation, which remember we talked about in last chapter. That's when water is released and a bond is formed. And most contain a mixture of more than one type of fatty acid in that one triglyceride. So with the saturation of these fatty acids, the location of the double bonds vary. And depending on where those double bonds of carbon to carbon instead of carbon to hydrogen, where those double bonds are, identify whether the polyunsaturated fatty acid is an omega-3 or an omega-6. And that will depend on its closest range to the methyl end of a fatty acid. And so let's talk about the saturated fatty acids. They are always fully loaded with hydrogens. The carbons are fully, in a sense, saturated with hydrogens, and there aren't any other bonds such as the double bond between carbon and carbon occurring. Unsaturated fats are called these because they do have a double bond. The presence of at least one double bond makes the fat unsaturated because not every carbon in that fatty acid tail is saturated to a hydrogen because it formed a double bond with a carbon. So when you're counting carbons to locate the double bond, you want to start at the methyl end. And that's also called the omega, and that's where you start counting to locate the double bond when you're trying to figure out what type of polyunsaturated fat it is, or what type of unsaturated fat it is. So looking at these saturated fats, all carbons are linked to a hydrogen only, and they contain no double bonds. Unsaturated fats are going to have one double bond, and polyunsaturated fats, that's when there is more than one double bond present. And so this summarizes the most common triglycerides that you're going to find in your food. They are the ones with an 18 carbon fatty acid chain, and as we talked about a little bit a few slides ago, the stearic acid, that's going to have 18 carbon atoms but 0 double bonds, so that makes it a saturated fat, and that's going to be found in most animal fats. Then we have the oleic acid, which is 18 also, but it has 1 double bond, which makes it a monounsaturated. That is the most common type of monounsaturated fat in food, and that's going to be linked with like olive and canola oils. Then we have the linoleic acid that has 18 as well, but 2 double bonds this time. It's polyunsaturated, and that is going to be such as sunflower, safflower, corn, and soybean oils. This type is also called the omega-6 fatty acid, and that's an example of an essential acid, fatty acid. And then the linolenic acid, that as well is an example of one of the essential fatty acids in our diet. That's going to be the omega-3s, and it does have 3 double bonds and is polyunsaturated because of it having more than one type of double bond. And those are going to be found in your soybean, canola oils, as well as flaxseed and walnut. So as we touched on a little bit that last slide, omega-3s, they're also called linolenic acid, and they are a type of polyunsaturated fat with those 3 double bonds. And remember, they name it the omega-3 by looking at the double bonds position away from the methyl acid head. And so when looking at a diagram, which we'll look at in the next couple slides, you'll see that the closest double bond to the methyl head is 3 carbons away. So that's where they get the number 3 from. And then the monounsaturated fatty acid, that is also considered omega-9. And that's because when you count the carbons from that methyl head, it is 9 carbons away, their double bond is. And so when you're looking at this, that is how you determine which one is which. So for A, that's the linolenic acid, because its double bond with carbon is 3 carbons away from the head. And I'm sorry, that one's B. B is the linoleic acid, also the omega-3. In A, you can see there that that's actually the 6th carbon away, and that's linoleic acid. That's the omega-6. And then lastly, C, that's the triglyceride. And that's just looking at what that type of lipid overall. And then remember then that a triglyceride would be that glycerol head, which is in the darker orange, and then consists of 3 fatty acid tails. And those omega-6, omega-3, that's an example of one different kind of fatty acid tail. And remember, we mentioned this before, that condensation is used to form the triglycerides between bonding the glycerol to the fatty acid tails. And as you can see, the result of bonding a tail to the glycerol head will result in 3 water molecules after you form the triglyceride, because there's 3 different bonds occurring there in condensation. And so moving on with characteristics of solid fats and oils, which fatty acid tends to be solid at room temperature? That's going to be those saturated fats. Remember that saturated fats normally are solid because their tails are straight, and so they stack well. They're very tight and condensed then. An example of saturated fat is butter. That's solid at room temperature. So fats with a double bond to have a kinked chain, and that's going to be an unsaturated fat. And so they don't stack as well, and they're mostly found as liquids at room temperature, like oil, like olive oil. Fats go bad when exposed to oxygen, but polyunsaturated fats spoil most readily, and heat and light exposure also speed up the process of fats going rancid. And so what we just talked about in this last slide, you can see how the saturated fatty acids tend to stick and stack better together because they are straight, and the unsaturated fats are more branched and kinked, and so that leads to their liquid consistency at room temperature. And so most fats are a mixture of saturated, monounsaturated, and polyunsaturated fats, because those, remember, triglycerides are often made of combination of different type of fatty acid tails. Not all saturated, but one's saturated, one's unsaturated, one's even more unsaturated, like polyunsaturated. So you're gonna get more than one type of fat in an example of like an oil, or if you look, animal fats and tropical oils like coconut and palm oil, those are going to be mostly saturated fatty acids. And then in the middle, the ones that are richer in monounsaturated fatty acids, that's going to be your olive oil, canola oil, peanut oil. Many vegetables oils are rich in those polyunsaturated fats, specifically omega-6s. That's going to be safflower oil, sunflower oil. You can see a few of the other ones. And then lastly, only a few of them are the polyunsaturated form with omega-3, and that's going to be flaxseed oil and fish oil. So now we're going to go over the process of hydrogenation and the difference between cis and trans. So cis and trans refers to how the hydrogens have configured around their double bond. With trans fatty acids, they have hydrogens on opposite sides of the double bond, whereas cis fatty acids have both hydrogens on the same side of the double bond. So you can remember it means the same. And with partial hydrogenation, That's most often during food processing where the double bonds remained but are changed from cis to trans. And total hydrogenation is when saturated fat is completely transformed from an unsaturated fat. But hydrogenation is that processing that deals with the development of trans fats, and we'll get into in a bit how dangerous those are for health. So this is a good illustration. Here the double bonds in a polyunsaturated fatty acid carry a slightly negative charge and are ready to accept positively charged hydrogen atoms. So they accept those hydrogen atoms and turn into a saturated fatty acid. Most often this will create a partially hydrogenated oil, and that itself is a trans fatty acid. And so you can see that in the cis, if we're looking, this is an example of a 18 carbon monounsaturated fatty acid and how it got configured to a trans lactic acid. And the hydrogens are on the same side of the carbon in the cis fatty acid, but then opposite sides in the trans. And that's due to the processing. And so now we'll look at phospholipids and sterols. And so a sterol is a compound containing a 4-ring carbon structure with any of the variety of fatty acid side chains. It varies for most of them, but that main important structure is the 4-ring carbon. And then with phospholipid, it's very similar to the structure of a triglyceride, but it only has 2 fatty acid chains, and it also has a corresponding phosphate group, which is a phosphorus containing a salt, and another nitrogen containing compound. Most often it's choline in the place of one of the fatty acids. So with sterols, they are cholesterol. An example of a sterol made by the body is vitamin D, and then they are structural components in cell membranes. Whereas a phospholipid, that is going to be the most common example of that found in food and in the body, is lecithin, and that's in a emulsifying compound. And phospholipids are soluble in fat and water due to its structure, and they form cell membranes. So you'll find a lot of phospholipids in the cell membranes of our body. So diving into phospholipids, a cell membrane is made of phospholipids assembled into an orderly fashion called a bilayer. You can see in that photo on the screen that it's very ordered, with a fatty acid tails going towards themselves from the watery fluid inside and outside the cell, and the glycerol and phosphate heads are attracted to the watery fluid. The food sources richest in lecithin are eggs, liver, soybeans, wheat germ, peanuts, but they're also used as emulsifiers in mayonnaise, salad dressings, and candy bars. Emulsifiers are very much so used by the food industry. As we said before, lecithin is the best known phospholipid used, and its important roles with emulsification and making up the cell membrane. Now with sterols, the most well-known form of sterol in food is cholesterol. Those only contain from animal sources like meats, eggs, seafood, poultry, and dairy products. Other sterols that are found naturally are found in plants. Sterols are good because they interfere with cholesterol absorption, so a diet that's high in plant sterols will consequently lower blood cholesterol levels. they have come up with fortifying certain fats with plant sterols like margarine, and by doing that, it creates a functional food that can reduce blood cholesterol. That's why for a while, margarine was advertised to be better than butter. That is debatable because butter is a more natural product, and functional foods, whether or not they're compatible with the body and absorption, that's been controversial. So that's why it's not really advertised as much. With food sources, being animal products with cholesterol and the plant sterols existing, sterols are very active with the diet and in the body as well. They are made by the body as sex hormones like estrogen, androgen, testosterone. They're made for bile acids, also adrenal hormones, cortisol, cortisone, and vitamin D, as we said before. Cholesterol itself in the body can serve as the starting material for synthesis of many compounds or structural components of cell membranes. 90% of the body's cholesterol is found in cells, and the compound is made and used by the body. Most cholesterol in the body is endogenous, which means that it's manufactured by the body itself. It's made by the liver from different fragments of carbohydrates, protein, and fat. Actually, your body makes between 800 to 1500 milligrams of cholesterol, and it's only recommended for you to consume 300 milligrams. So most of the cholesterol your body is making. And when it's eaten, that makes it exogenous, and the harmful effects that can occur from consuming too much exogenously would be it accumulating in artery walls and contributing to plaque, and then that plaque buildup has been linked to causing heart disease and heart attacks due to atherosclerosis. So fats are hydrophobic and digestive enzymes are hydrophilic. And so constantly the body and digestive system is trying to meet the challenge of keeping the lipids mixed with the watery fluids of the digestive tract so that they can facilitate and work with the lipases, which digest the fats. Each day with your food, you consume between 50 to 100 grams of triglyceride, 4 to 8 grams of phospholipid, and 300 milligrams of cholesterol. And the goal of fat digestion is to dismantle those triglycerides into the smaller subunits, monoglycerides, fatty acids, and glycerol. If we look at the fat digestion in the GI tract, it starts in the mouth with those salivary glands, and some hard fats begin to start getting digested when they reach body temperature. The sublingual salivary gland secretes the lingual lipase, and the degree of hydrolysis by that lingual lipase is slight for most fats, but it will really start breaking down those milk fats. Once it enters the stomach churning action mixes the fat with the water and the acid, that's being its own emulsifier. And the gastric lipase accesses and hydrolyzes, again, only a small amount of fat because most of the breakdown and digestion of fat occurs in the small intestine so it can be properly absorbed. This is going to begin with the CCK, that's the hormone that signals the gallbladder to release bile. And then bile will come through the bile duct into the small intestine. And that bile is important for emulsifying the fats with the digestive enzymes. the pancreas produces the digestive enzyme lipase, and that flows in from the pancreas through the pancreatic duct. And then those emulsified fats mix with the pancreatic and intestinal lipases and break down into the monoglycerides, glycerol, fatty acids, which can then be absorbed by the small intestine. So here are some notes that highlight what we just went over in the diagram, how it starts with the mouth and the stomach, but remember most of the fat digestion really occurs in the small intestine. But there will be some breakdown with the lingual lipase in the mouth, the gastric lipase. Remember, the stomach plays an important role with emulsifying them in the beginning with its muscle contractions. And then once it hits the small intestine, the hormone CCK is responsible for signaling the gallbladder to release bile. And bile acids in the bile are made in the liver from cholesterol. So the bile pairs up with hydrophilic amino acids to act as an emulsifying agent. And then it will have the ability to mix the lipase enzyme secreted by the pancreas and small intestine with the fats. As the enzymes remove the outer fatty acids of triglycerides, they leave the monoglycerides with hydrolysis. That's a process it uses to break down triglycerides. Phospholipids are digested similarly, with fatty acids being removed with hydrolysis as well. Fatty acids, glycerol, and phosphate fragments can then be absorbed. Also, most sterols are absorbed as is, but any fatty acids that may be attached to the sterol need to be hydrolyzed first. After the bile emulsifies, most of its extra nutrients are reabsorbed back into the small intestine to be used and recycled. Some get trapped by fiber and in the large intestine and then are excreted. Remember, those are the soluble fibers that can do that, fruit, whole grains, and legumes. And this excretion of the bile is beneficial because it ultimately lowers then your cholesterol levels in the blood, as the liver will need to take more cholesterol from the blood to remake the bile, and it's getting it out of your system so it doesn't get reabsorbed back in. So this is just a diagram that looks at the science behind how the bile is in an emulsifier for the fat. Like bile, detergents are emulsifiers and work the same way. That's why they're effective in removing grease spots from clothes. Molecule by molecule, the grease is dissolved out of the spot and can be suspended into water where it then is rinsed away. So think of that in the same way. Remember, triglycerides are broken down in the digestive process with hydrolysis. Remember, hydrolysis, it uses the water molecules to split the bonds between the glycerol head and the fatty acid tails. And then when the triglyceride is getting broken down, it removes the outer fatty acid tails first. So then it will leave that remaining monoglyceride and then the freely floating fatty acids and glycerol head to be absorbed into the small intestine. This is the circulation. Most of the bile released into the small intestines is then reabsorbed back into the liver, which we talked about, to get reused. This cycle is called the enterohepatic circulation of bile. Remember, hepatic means liver. And some bile is excreted. It starts, remember, here we'll go over the answers too. In the liver, bile is made from cholesterol. Then in the gallbladder, bile is stored. In the small intestine, bile emulsifies fat. It's either reabsorbed or bile trapped by soluble fibers is excreted in feces. With lipid absorption, the ones that are absorbed directly into the bloodstream are glycerol, short and medium chain fatty acids. All three of these are small enough to easily cross the intestinal cells and then enter into the bloodstream. So, as we said, the small molecules can diffuse easily, but the larger molecules, like the monoglyceride that gets left in the middle for breaking down triglycerides, and then those long fatty acid chains, they must first be emulsified by bile and form spherical micelles, and then they can diffuse into the intestinal cells. And so that happens, they're reassembled into triglycerides once they pass through the small intestine. And then newly triglycerides, cholesterol, and phospholipids are packaged with protein into transport vehicles, in this case chylomicron, and that's a type of lipoprotein. And then it's released by the intestinal cells into the lymphatic system. It then glides through the lymph till reaching the point of entry into bloodstream at the thoracic duct, which remember is near the heart. And also remember that any GI nutrients that enter the lymph first bypass the liver. Then the blood carries the lipids to the rest of the part of the body for either immediate storage, immediate use for energy, or storage. So the end products of fat digestion, again, are mostly monoglycerides, some fatty acids, and a little glycerol, and their absorption differs depending on their sizes. In reality, molecules of fatty acids are too small to even see through a powerful microscope, but that selective membrane of the small intestinal walls will be able to keep out even small molecules in real life, like fatty acids. And so this diagram does a good job at explaining what we just went over in the last slide. With glycerol and small lipids, such as short and medium chain fatty acids, those can move directly into the bloodstream, whereas the large lipids will have to go through that process of forming into the micelles and then getting absorbed across the membrane and then turning into the lipoproteins so that they can be carried and transformed through the body. So this is just a good review. Those chylomicrons, those are going to contain the highest amount of triglyceride and are therefore the least dense. The very low density lipoproteins, those are made in the liver and then shrink in the bloodstream as cells take up triglycerides. Then low density lipoproteins, those contain the highest amount of triglyceride and are therefore the least dense. And high density lipoproteins, those carry cholesterol back to the liver for recycling or excretion. Also remember that the low density lipoproteins, those have high levels of lipoprotein, which can negatively affect your health. HDL is considered the good cholesterol, and LDL is considered the bad cholesterol. Ways to remember this, ways to lower LDL and raise HDL include weight management, replacing saturated and saturated fats with mono and polyunsaturated fats, soluble fiber, and enough physical activity. As we saw in the last slide, there are multiple types of lipoproteins that assist in carrying cholesterol and the lipids. The 4 types of lipoproteins that we just went over are the chylomicrons, the very low density lipoproteins, the low density lipoproteins, and the high density lipoproteins. Lipoproteins in general are clusters of lipids with proteins that serve as transport vehicles for lipids in the lymph and the blood. They solve the body's problem of transporting fat through a water-polar bloodstream, and more lipids are less dense, and with more proteins, that's going to make it more dense. The chylomicrons, those are the largest and least dense. They are diet-derived, and they get smaller as triglyceride portions are removed as it goes to the cells. The VLDL is composed mostly of triglycerides. It's made by the liver, though. It doesn't come from food. It's transported, and it transports the lipids to the tissues, and it gets smaller and more dense as triglycerides portion and are removed. And then the LDL is mostly of cholesterol, and those transport lipids to the tissues. The HDL, those transport cholesterol from the cells to the liver, and they'll have anti-inflammatory properties as well. With the lipid transport, this is a good diagram that summarizes what we went over. The liver cells synthesize the lipids, and those liver cells form HDL, which pick up cholesterol from the body cells, so they'll make their circuit around, and then HDL will deliver cholesterol to the liver for excretion. And the liver cells that form VLDL, those that deliver mostly triglycerides to the body cells, those are going to go to the fat cells. And as cells remove lipids from the VLDL, they'll get smaller, and then they'll return back to the liver. Or they'll deliver even more of its lipids to the body cells, like the muscles. And the liver cells that form the VLDL either go to fat cells or muscles. With liver cells, the small intestine absorbs the fat and the lipids, and chylomicrons take it and deliver it as dietary lipids to most of the body cells through that transport. And it will go also to muscle and fat cells that we talked about. As those cells remove the lipids from the chylomicrons, they get smaller. And the liver cells also receive small lipids directly from the intestine that go right through. Those were those glycerols and small fatty acids. So the roles for triglycerides, they provide the cells with energy. It's virtually unlimited ability to store fat energy. And that's due to the adipose tissues that store body fat. Those are also responsible for secreting hormones. These are adipokines. And other uses of the fat in the body include skin insulation, shock absorption, cell membrane material, and cell energy pathways. With an adipose cell, its newly imported triglycerides first form the small droplets on the outsider edge of the cell, and then they merge with the large central globule. The large central globule, that's going to be pure fat in the cell. Then you got the cell nucleus on the edge, cytoplasm, and as the central globule enlarges, the fat cell membrane extends to accommodate its swollen content. So that's why it's stored. So as we talked about linoleic acid and linolenic acid in the beginning, those are the omega-3 and omega-6 fatty acids, and either of those fatty acids can be used to make even longer complex fatty acid chains. Remember, those two are the most common that you get through food consumption, and they have 18 carbons, but with elongating them and adding carbons, the carbon chain can get longer, as well as desaturating them further to create more double bonds on that chain. For example, the omega-6 fatty acid, linoleic acid, that can be desaturated and elongated and then desaturated again to form the arachidonic acid. And similarly, the omega-3 fatty acid can be elongated to form fatty acids like EPA and DHA from its original 18 carbon structure. And the linoleic acid is the omega-6, remember. That's essential fatty acid because your body can't make it. And sources of that is the vegetable oils and meats. And then linolenic acid, that's the omega-3. It's essential, must be supplied by food, and that can also make the DHA and EPA for the extended, elongated fatty acids. And then eicosanoids, those are hormone-like. They do have several health benefits, such as being able to decrease the risk of high blood pressure. They interact with cells around them, and they help lower and prevent blood clotting and protect against irregular heartbeat. More specifically, those are the omega-3 eicosanoids, and they can also do this with participating in immune system responses. A correct omega-6 to omega-3 ratio is controversial of how much there should be in that ratio. Experts disagree. And with fatty acid deficiencies, those are rare in the United States, especially with the omega-6 fatty acid. A deficiency is not common. Sometimes there's often overconsumption of the omega-6s. And with that, some symptoms can occur, though, in infants and children that are following a fat-free or low-fat diet. They will experience deficiencies from those fatty acids not being absorbed in their diet. This is a good summary for adipose cells. Those store fat after meals. Lipoprotein lipase, that's what hydrolyzes the triglycerides to break those down. The fat supplies 60% of the energy needed during rest. And during times of energy deprivation, fat and lean protein tissue are used for energy. And with storing fat as fat, the lipoprotein lipase is LPL that hydrolyzes triglycerides, and those components will be reassembled into triglycerides for storage within the adipocytes. There are hormone-sensitive lipase that dismantles the triglycerides within the adipocytes for its release into blood so that it can be used for energy. And that's when, if fasting is occurring and there isn't being enough energy intake through glucose, they'll use those fat reserves in the adipocytes, and even could lead to muscle wasting by using lean protein tissue as well. There should be a focus on quality and quantity when trying to control your fat intake, and whether or not looking at is this saturated fat or mono and unsaturated fat. As we talked about in the last few chapters, trans fat should be not in your diet at all. You should try to completely eliminate that, as that increases your LDL and lowers your HDL cholesterol. And saturated fats should be limited, and a proper way to lower your intake of saturated fat is by trading it out with unsaturated fats. Currently, the U.S. diet contains excessive amounts of solid fats, and the blood lipid profile is very high, too high. The concentrations in that blood lipid profile, they reflect the amount of lipids in the blood. And the total cholesterol should be less than 200, LDL cholesterol less than 100, HDL should be greater than 60, and triglycerides should try to be less than 100 milligrams as well. Heart disease is prone when these LDL cholesterol levels are increased, when cholesterol accumulates in the arteries and restricts the blood flow and then can raise blood pressure. And cancer is, with dietary fat, is an association that with more dietary fat, there's an increased risk of some types of cancers, and that can promote the growth of cancer. There are stronger relationships of fat intake to specific cancers than others. And also with obesity, there's a high fat intake that's combined with inactivity that can lead to really significant weight gain. So as we talked before, there's that promoting factor with a high fat diet and increased risk of cancer. And of course with obesity, cutting fat from the diet will often reduce your calorie intake because fat is a higher caloric value per gram than the other macronutrients. And you want to be looking at those dietary recommendations and following them to prevent yourself from consuming too much fat. The DRI and dietary guidelines for fat consumption is 20 to 35%. On average in America, we consume 34% in our diet, so the fat intake is good for Americans. Less than 10% from saturated fat. Right now, the average is 11%, so it's a little high. And with cholesterol, it should be below 300 milligrams of cholesterol. Remember, your body, your liver is creating between 800 to over 1,000 grams every day, so you don't need to consume that much in your own diet. Right now, about 224 milligrams is the approximate consumption for females and 333 for males. So males tend to consume more cholesterol than they need to. And to avoid getting too little fat in your diet, that is just as important as not consuming too much fat diet, because fat is very important. As we've talked about, its processes in those cell membranes and creating cells and providing the nutrients for extra energy storages. There's just a lot of important tasks of fat that there are very big health risks if you're not consuming enough. So just as it is to watch that you're not consuming too much, make sure that you are consuming enough and of the right ones that provide you with more nutrients, like the unsaturated fats. So here's a good review. Replacing saturated fats with unsaturated fats can help reduce your risk of heart disease. The regular consumption of omega blank fatty acids suppresses blank, which may protect against some cancers. That's going to be those omega-3s, and that helps suppress inflammation. Fish oil supplements are especially high in omega-3s, and those are available but not recommended for routine supplementation because you don't want to have an over intake of your omega-3s. But eating fish often is really recommended. The normal recommendation is at least twice a week to eat fish, and that will make sure you're getting your sufficient needs of the essential fatty acids, omega-3s. Portion sizes is also very important, and they've been adjusted so that you aren't having too much of a specific food that's going to lead to an over increase of your fat intake. You want to replace butter, bacon, potato chips, cheese, steak with other alternative unsaturated fat sources: olive oil, sunflower seeds, mixed nuts, avocados, and salmon. And we did go over that recommendation before, 20 to 35% of your calories being from fat. This does include the essential fatty acids, omega-3s and 6s. The DRI recommends for omega-3s 0.6 to 1.2% and 5 to 10% for the linoleic omega-6 fatty acids. When you're making your grocery selection, it is important to remember the best choices of protein are the lean ones that will be lower in their saturated fat content. It's important to buy groceries that have the healthy fat components because fats can also provide sources of fat-soluble vitamins, A, D, E, and K, which are very important to your health as well. Leaner meat alternatives would be seafood, poultry, chicken, turkey, and soy, as well as milk and milk products. The best choices for those are the fat-free and low-fat milks and dairy products. This is looking at for your fat cuts. You want to take a smaller portion size of a less lean meat. If you are consuming a lean meat, then your portion size can be bigger than when you're consuming more of those saturated fat meat, such as pork and red meat and things. But as long as you limit your portion size, it's okay to consume that. And then with potatoes, eating a plain potato is much healthier than adding the extra fat with the butter and choosing the fat-free or skim milk. Vegetables, it's important to consume a wide variety of vegetables, fruits, and grains in your diet. With solid fats and oils, avoid those invisible fats from high-fat cheese products or baked and fried foods. And reading labels, that is very important because something can be very deceiving and seeming like it's healthy, but if you check those saturated fats, those cholesterol values, then you'll be able to make a better informed decision. And also fat replacers, those are controversial, definitely, because they are either derived from carbohydrates, protein, or fat sources, but a fat replacer by definition with artificial fats, that's a zero energy fat replacer that are chemically synthesized to mimic the sensory and cooking qualities of a natural occurring fat without the extra caloric and saturated fat values. Olestra is an example of a synthetic fat that's made from sucrose and fatty acids. It provides 0 calorie per gram because it doesn't get absorbed by the body once it reaches the small intestine. It's approved by FDA, and there are no known risks of it developing health problems like cancer, but it does rob your nutrients by binding to nutrients like fat-soluble vitamins, D, E, K, and A, and then removing those as they're excreted. So, in response, they have made Olestra fortified with those vitamins, but you're still not getting it from the raw natural foods, which is the best way and leads to optimal absorption into the body. Alternatives can help lower energy intake and support weight loss, but only when they actually replace the fat and energy in the diet, and it's not just an additional consumption. And so lastly, we'll look at the highlight of high-fat foods, whether they are friend or foe. You want to generally lower your saturated and trans fat intake with moderate calories. It's enough fats for good health, but not too much, because that will be harmful. And educating the consumer on the different types of fat is very important as well. With the DR recommendations, it's compatible when you follow those, that you're at lower risk for developing diseases. The higher fatty foods that are okay and going to benefit your health are the olive oil and nuts, because their levels are higher in the unsaturated fats. There's a lot of benefits for heart health by replacing those saturated fats with unsaturated. The fat composition of nuts can also be beneficial for making one feel full later on in the day, for heart health and lowering your LDL and inflammation, as well as blood pressures. And you do need to be cautious of the dietary inclusion of nuts, as they can be sometimes as well high in saturated fats and calories. So make sure you're consuming those with a mindful proportion. And with fish, you really should consider adding fish to your diet either daily or at least 2 times a week. They're rich in long chains of the omega-3 essential fatty acids. There is an environmental caution for mercury contamination and consumption, especially for pregnant and lactating women and of young children. With saturated fat, the main detriment is the LDL cholesterol levels that it increases. Sources of saturated fat are red meats, whole milk products, tropical oils that we talked about, the coconut oil. You need to read the food labels and choose the lowest in saturated fat. Choose leaner and lower fat animal products like poultry, seafood, as we talked about. And for trans fat, limit your ingestion of trans fat in general. And that will be by making sure to check the food label and that there are no hydrogenated oils. When you're comparing 2 meals, this is a high content saturated fat meal versus an unsaturated fat meal. And it's going to be a lot better for you. Although it's equal in calories, you're going to consume a lot less fat, and the fatty sources are healthier if they are unsaturated. The Mediterranean diet is a great diet to consider because it's linked with many good health improvements, but it may not be the only factor. There's a lot of factors that are considered with choosing the Mediterranean diet. But foods in this diet are fish, seafood, that's going to be incorporating olive oil, limiting your meat overall, more whole foods, vegetables, legumes, fruit, and more fiber and phytochemicals will be in your diet as a result. And there's going to be low to no intake of trans fat and low saturated fat. So lastly, looking at the Mediterranean diet with this food pyramid, it's also important to drink lots of water throughout the day. There is an incorporation of wine with the Mediterranean diet that shows some health benefits with moderation, and being physically active as well. In conclusion, saturated fats and trans fats are linked to poor health with excessive consumption. So limit your consumption of the saturated fats and sub them for the more positive, correlated, unsaturated, healthy fats.